Have you ever noticed how some places on Earth feel shaped by forces powerful enough to rewrite the land? In this episode of Unearthed Secrets, we explore an awakening volcano, a world-ending impact, a waterless desert, a hidden cave world, a collapsed mountain, and a vanishing sea. Like and subscribe, and tell us where you're watching from and what time it is for you right now. The volcano that awoke. For centuries, Mount Sinabung stood quietly above the highlands of northern Sumatra, a forested peak rising calmly among farms and villages. Generations were born, lived, and died in its shadow without ever seeing fire or ash. Local memory held no stories of eruption. Maps listed it as dormant. Life adapted to its presence as something permanent and benign. Then, in 2010, without long warning or gradual unrest, Sinabung woke up. What followed was not a single eruption, but a transformation, from a silent mountain into one of Indonesia's most dangerous and persistent volcanoes. The Mount Sinabung rises to about 2,560 meters above sea level in Karo Regency, North Sumatra. It is part of the vast Sunda Arc, a chain of volcanoes formed where the Indo-Australian plate is forced beneath the Eurasian plate. This tectonic boundary feeds hundreds of volcanoes across Indonesia, making the country one of the most volcanically active regions on Earth. Yet Sinabung was different. Unlike neighboring volcanoes with long records of eruption, Sinabung had been quiet for at least 400 years. Its slopes were densely populated. Fertile volcanic soils supported agriculture, corn, vegetables, coffee. Villages clustered close to the mountain. There was no living memory of danger. That false sense of security would not last. In August 2010, Sinabung erupted suddenly, sending ash several kilometers into the air. Residents fled in confusion. Authorities scrambled to respond. The eruption subsided after weeks, and many believed it to be an isolated event. It was not. From 2013 onward, Sinabung entered a prolonged eruptive phase that continues intermittently to this day. Unlike brief explosive eruptions, Sinabung's activity became sustained and destructive, dominated by lava dome growth and collapse. This behavior is particularly dangerous. Sinabung is a stratovolcano built from layers of lava, ash, and fragmented rock. Its magma is viscous, thick, and sticky, preventing gas from escaping easily. Instead of flowing smoothly, lava piles up near the summit, forming unstable domes. As these domes grow, they become increasingly unstable. Eventually, parts of the dome collapse under their own weight, or due to internal pressure. When they do, they generate pyroclastic flows, fast-moving clouds of superheated gas, ash, and rock that race down the slopes at speeds exceeding 100 kilometers per hour. These flows are deadly. They hug the ground, follow valleys, and incinerate everything in their path. Temperatures can exceed 500 degrees Celsius. There's no outrunning them. Survival depends entirely on distance and timing. Sinabung produced dozens of such flows between 2013 and 2021. Entire villages were evacuated permanently. Thousands of people were displaced. Some areas became exclusion zones where return was forbidden. Farmland that had sustained families for generations was buried under ash and debris. In 2014, a series of powerful pyroclastic flows killed at least 16 people, including journalists and local residents who had ventured too close. The tragedy underscored how unpredictable Sinabung had become. The volcano did not erupt in a single catastrophic blast. It eroded lives slowly, relentlessly. Ashfall became routine. Roofs collapsed under accumulated weight. Crops failed repeatedly. Water sources were contaminated. Respiratory illnesses increased. What made Sinabung especially difficult to manage was its persistence. Many volcanoes erupt violently, then quiet down. Sinabung did not. It entered a cycle of dome growth, collapse, ash emission, and gas release that lasted years. Each quiet period raised hope. Each renewed eruption destroyed it. From a scientific perspective, Sinabung became a critical case study. Monitoring stations recorded seismic tremors, gas emissions, and ground deformation. Satellites tracked ash plumes drifting hundreds of kilometers. Thermal imaging revealed dome growth hidden beneath clouds. Scientists learned that Sinabung's magma supply was continuous. Deep below the surface, magma kept rising, feeding the dome again and again. There was no simple endpoint. Sinabung had shifted categories, from dormant to active. This reclassification carries serious implications. Volcanoes considered dormant are often poorly monitored. Populations grow around them. Emergency plans fade. Sinabung demonstrated that dormancy does not mean extinction. A volcano can remain silent for centuries and still awaken violently. Indonesia has many such volcanoes. Sinabung's awakening forced authorities to rethink hazard assessments nationwide. Geologically, Sinabung's behavior reflects the nature of subduction zone volcanism. Water released from the descending oceanic plate lowers the melting point of mantle rock, generating magma rich in silica. This magma is explosive by nature. The volcano's internal structure also plays a role. Older lava layers, fractures, and collapsed conduits create complex pathways for magma and gas. Pressure builds unevenly. Failures occur suddenly. Above ground, the landscape around Sinabung has been reshaped. Pyroclastic deposits blanket valleys. Lahars, volcanic mudflows triggered by rain mixing with ash, have carved new channels. Forests near the summit are stripped bare. What was once green is now gray and scarred. And yet, life continues. Some residents have returned to marginal areas, drawn by the same fertile soil that once sustained them. Others remain displaced, living in temporary housing for years. Cultural ties to land are difficult to sever, even when danger persists. Sinabung has become part of daily life, not as background scenery, but as an ongoing threat. At night, the volcano sometimes glows faintly at the summit. Ash plumes rise silently under moonlight. On clear days, the mountain looks deceptively peaceful. This contrast is what makes Sinabung unsettling. There's no constant roar, no continuous lava flow. Only the knowledge that collapse can occur at any moment. The mountain does not give clear warnings. Seismic signals may increase, but exact timing remains uncertain. Evacuation zones shift as conditions change. Residents live in a state of extended anticipation. Sinabung has also altered scientific understanding of volcanic timeframes. Human systems often operate on short cycles, days, months, years. Sinabung operates on geological cycles that do not align with human patience. Its eruption is not an event. It is a phase, and phases can last decades. Climate interacts with this hazard as well. Heavy rains increase lahar risk. Ash clouds affect regional weather and aviation. Volcanic particles influence air quality far beyond the immediate area. The volcano's impact is layered: physical, social, economic, psychological. From space, Sinabung's eruptions appear as gray plumes spreading across Sumatra. From the ground, they are louder, closer, heavier. Ash settles on skin. Breathing becomes difficult. Vision narrows. These are not distant disasters. They are lived realities. Despite modern monitoring, Sinabung cannot be controlled or predicted with precision. Science reduces risk. It does not remove it. This uncertainty forces a difficult balance between safety and livelihood. How far is far enough? How long is long enough to stay away? When does evacuation become permanent? There are no easy answers. Mount Sinabung stands as a reminder that volcanic risk is not limited to famous or frequently active peaks. It shows how quickly a landscape and a society can be redefined by geological forces long assumed to be dormant. It also reminds us that the Earth does not operate on human timelines. Silence does not mean safety. Calm does not mean stable. In North Sumatra, a mountain once ignored now commands constant attention. Its slopes tell a story written not in myth, but in ash, stone, and displacement. Mount Sinabung is not the loudest volcano in Indonesia. It is not the largest. It is not the most explosive, but it is one of the most instructive. A volcano that waited. A volcano that returned. A volcano that refuses to be forgotten. In a land shaped by fire, Sinabung reminds us that the past is not always over, and that even centuries of quiet cannot guarantee peace beneath the ground. The impact that reset life. Beneath the flat limestone plains and shallow coastal waters of Mexico's Yucatan Peninsula lies a scar so vast it cannot be seen from the ground, so old it predates human history entirely, and so powerful it altered the course of life on Earth. There's no towering crater rim, no visible chasm, no obvious sign of catastrophe. And yet, hidden beneath the layers of sediment and sea, the Chicxulub crater marks the site of one of the most consequential events in planetary history. The Chicxulub crater is the buried remnant of a massive asteroid impact that occurred approximately 66 million years ago, at the end of the Cretaceous period. That single event triggered a chain reaction of environmental collapse that led to the extinction of roughly 75% of all species on Earth, including all non-avian dinosaurs. This was not just an impact, it was a planetary turning point. The asteroid that struck Earth is estimated to have been about 10 to 15 kilometers wide. It traveled at speeds exceeding 20 kilometers per second. When it struck the shallow sea covering what is now the Yucatan Peninsula, it released energy equivalent to billions of atomic bombs, detonating simultaneously. The ground did not merely crack, it behaved like liquid. Rock vaporized instantly. The crust rebounded violently. Shockwaves rippled through the planet. Within seconds, a crater nearly 180 kilometers wide and more than 20 kilometers deep formed, one of the largest known impact structures on Earth. And then the effects spread outward. The immediate impact produced temperatures hotter than the surface of the sun. Anything within hundreds of kilometers was incinerated instantly. A towering plume of vaporized rock blasted into the upper atmosphere, ejecting debris far beyond Earth's gravitational pull. Molten rock rained back down across continents. Wildfires ignited worldwide. Mega tsunamis surged across ancient oceans. But the most devastating effects were not immediate. They unfolded over months and years. Fine dust, sulfur aerosols, and soot filled the atmosphere, blocking sunlight. Global temperatures plummeted. Photosynthesis collapsed. Food chains unraveled from the bottom up. This period, often called an impact winter, transformed Earth into a hostile world almost overnight. Dinosaurs, dominant for over 160 million years, could not survive it. For decades, the cause of their extinction was debated. Volcanism, climate change, and gradual decline were proposed. But a key clue emerged in the late 20th century. A thin layer of clay found worldwide, rich in iridium, an element rare on Earth's surface but common in asteroids. This layer marked a moment in time, a boundary, a line separating the age of dinosaurs from what came after. The question remained, where was the crater? In the late 1970s and early 1980s, geophysicists studying gravity and magnetic anomalies beneath the Yucatan Peninsula noticed something unusual. A massive, circular structure buried beneath limestone and sediment. Oil exploration data hinted at concentric rings and fractured rock. The structure was named a Chicxulub after a nearby village. At first, the idea that this buried feature was the dinosaur-killing crater was controversial. It was hidden. It was eroded. It was invisible to the naked eye. But evidence continued to accumulate. Drill cores recovered shocked quartz, minerals altered only under extreme pressure. Melt rock consistent with impact conditions was identified. The size and age matched the extinction event precisely. By the 1990s, consensus formed. Chicxulub was the crater, and Chicxulub changed everything. One of the most important discoveries came from deep drilling projects in the 21st century. Scientists confirmed the presence of a peak ring, a circular mountain range formed when the Earth's crust rebounded after impact, similar to what is seen in craters on the moon. This peak ring provided critical insight into impact physics. The rocks found there originated from deep within the crust, uplifted violently in seconds. Their structure showed extensive fracturing, making them porous, ideal for hosting microbial life long after the impact. Ironically, a site of mass death may have later become a cradle for new life underground. The location of Chicxulub amplified its destructive power. The asteroid struck a carbonate-rich platform filled with sulfur-bearing rocks. When vaporized, these materials injected massive amounts of sulfur dioxide into the atmosphere, forming reflective aerosols that intensified global cooling. Had the asteroid struck elsewhere, deep ocean or basaltic crust, the outcome might have been different. But it struck here. Timing and place aligned with a devastating precision. In the oceans, plankton populations collapsed. Acid rain fell worldwide. Coral reefs died. On land, forests burned, then froze. Large animals starved. Only adaptable, small, and opportunistic species survived. Among them were mammals. At the time of the impact, mammals were small, nocturnal, and marginal. The extinction of dominant reptiles opened ecological space. Over millions of years, mammals diversified, eventually leading to primates, and much later, humans. This makes Chicxulub not just a symbol of destruction, but of redirection. Without it, Human existence is uncertain. Geologically, the crater is still active in subtle ways. The fractured rock beneath the Yucatan influences groundwater flow. The region's extensive cenote system, sinkholes connected by underground rivers, may be partially guided by the impact's structural weaknesses. In this way, the crater continues to shape the surface long after its formation. Despite its importance, Chicxulub remains largely invisible. There's no rim to stand upon, no crater wall to descend. Its presence is known through data, gravity maps, drill cores, seismic surveys. It exists more as a concept than a landmark. And yet, it is very real. From space, faint circular patterns can be detected in topography and coastline alignment. From beneath the surface, broken rock tells a story of violence unmatched in Earth's recent history. Chicxulub reframes how we understand extinction. It shows that life on Earth is resilient, but not invulnerable. That dominance offers no protection. That change can arrive suddenly, from beyond the planet itself. It also reshaped scientific thinking. Before Chicxulub, mass extinctions were often attributed solely to slow processes. After Chicxulub, cosmic impacts became recognized as real, existential forces capable of reshaping biospheres. This understanding now informs planetary defense efforts, tracking near-Earth objects, modeling impact risks, and considering mitigation strategies. Chicxulub is no longer just history. It's a warning. Not that such impacts are frequent, they are not, but that Earth exists within a dynamic cosmic environment, over geological. Time chance plays a role no species can ignore. Standing on the Yucatan today, nothing feels dangerous. The land is flat, the sea is calm. Tourists visit beaches unaware that beneath their feet lies the boundary between two worlds. One before the impact, one after. The dinosaurs never saw it coming. No species could. The Chicxulub crater is proof that Earth's greatest changes do not always rise from within. Sometimes they arrive from the sky, fast, silent, and unstoppable. A moment, a collision, a reset, and from that reset, the modern world emerged. Hidden beneath Mexico's quiet peninsula, Chicxulub remains the scar that ended one age and made another possible. A reminder that life on Earth exists not by permanence, but by survival through catastrophe. The landscape carved without water. In northern Chile, at the edge of the driest desert on Earth, there's a landscape that feels stripped of everything familiar. No rivers run through it, no vegetation softens its edges. The ground is fractured, rippled, and folded into sharp ridges of stone and salt. Dunes rise beside rock that looks torn open rather than eroded. At sunset, the land shifts in color, gray to gold, gold to red, red to violet, before fading into shadow. This is the Valley of the Moon, a place shaped not by abundance, but by absence. The Valley of the Moon, known locally as Valle de la Luna, lies within the Atacama Desert near the town of San Pedro de Atacama. The name is not poetic exaggeration. The terrain is so barren, so geologically exposed, that it has been used repeatedly as an analog for the surface of the Moon and Mars. Here, Earth resembles another world. The Atacama Desert exists because almost nothing reaches it. Moisture from the Pacific Ocean is blocked by the cold Humboldt Current, which suppresses evaporation and cloud formation. Any remaining moisture moving eastward is stopped by the Andes Mountains, which force air upward and strip it of water. Between ocean and mountains, the Atacama is starved of rain. Some areas receive no measurable rainfall for decades. In this environment, the Valley of the Moon formed without the shaping force most landscapes rely on, flowing water. Instead, its story is written in salt, pressure, wind, and time. Millions of years ago, this region was part of a vast basin, influenced by tectonic movement along the edge of the South American plate. As the Andes rose, the land compressed, folded, and fractured. Ancient lakes and shallow seas periodically filled the basin, then evaporated completely, leaving behind thick deposits of salt and gypsum. These deposits are central to the valley's appearance. Salt behaves differently from ordinary rock. Under pressure, it flows slowly, deforming rather, then cracking. Over time, layers of salt were pushed upward, folded, and exposed at the surface. Wind then sculpted these layers into sharp ridges and knife-like crests. What emerged was not smooth erosion, but structural exposure. The ground here looks peeled back. Layers are visible. Nothing is hidden. In places, the salt forms crusts so thick they crack like ice underfoot. In others, it rises into jagged walls that reflect sunlight harshly. The absence of moisture prevents these formations from dissolving or softening. Once exposed, they remain. Wind is the dominant sculptor. In the Valley of the Moon, wind does not carry moisture. It carries abrasion. Sand grains driven by persistent desert winds act like cutting tools, scouring exposed surfaces. Over thousands of years, wind has carved caves, undercuts, and wave-like patterns into rock. But unlike coastal erosion, this process lacks rhythm. There are no tides, no floods, no seasonal flow. Erosion happens continuously and unevenly. This creates the valley's most distinctive feature, unpredictability. Ridges twist abruptly. Dunes form beside solid rock. Sharp edges give way suddenly to smooth curves. The terrain resists interpretation. There's no obvious logic to movement or scale. Walking through the valley, distances feel distorted. Features appear closer than they are. The horizon shifts constantly. Without vegetation or landmarks, orientation becomes difficult. Sound behaves differently as well. The landscape absorbs noise rather than echoing it. Wind moves quietly. Footsteps crunch against salt and stone. Silence feels physical. The dunes in the Valley of the Moon are not typical sand dunes. Some are composed of fine, pale sand shaped by wind into steep slopes. Others contain darker mineral grains. Their forms are influenced by surrounding rock walls, which funnel wind and create complex airflow patterns. One dune in particular is known for a phenomenon called singing sand. When conditions are right, sand avalanching down its slope produces a low, resonant sound. The cause lies in grain size, shape, and dryness, conditions perfected by the Atacama's extreme aridity. Again, absence creates effect. The valley's colors are deceptive. At midday, the land appears bleached and monochrome. White salt, gray rock, pale sand. But as the sun lowers, iron-rich minerals catch the light. Reds and oranges intensify. Shadows deepen. Surfaces that looked flat reveal texture. Sunset is transformative. For a brief window, the valley looks alive with color. Then the light disappears quickly, and the temperature drops sharply. Heat escapes into the open sky. Cold settles in. This rapid shift reinforces the sense that the valley exists outside normal rhythms. Life here is minimal, but not entirely absent. Microorganisms survive within salt crystals, protected from radiation and desiccation. Some bacteria use salt itself as shelter. These extremophiles are of great interest to scientists studying the limits of life. If life can survive here, it may survive elsewhere. This is one reason space agencies study the Atacama extensively. The Valley of the Moon has been used to test Mars rovers and instruments, not because it looks alien, but because it behaves similarly. Soils are chemically harsh. Organic matter is scarce. UV radiation is intense. Conditions approximate those on Mars more closely than almost anywhere else on Earth. Human history in the valley is subtle. Indigenous peoples lived in the broader Atacama region for thousands of years, adapting to its extremes through careful water management and seasonal movement. While the valley itself offered little in terms of resources, it existed within a network of trade routes and cultural landscapes. Its emptiness was known and respected. In modern times, the valley became a destination not for survival, but for observation. Scientists, astronomers, and visitors drawn by its starkness came to experience a place largely untouched by biological activity. Protection followed. The Valley of the Moon is now part of a protected reserve, limiting access and development. This protection is necessary. The salt crusts are fragile. Foot traffic can permanently damage formations that took thousands of years to form. Once broken, they do not reform. Climate change introduces new uncertainties. While rainfall remains extremely low, even small changes could alter surface chemistry. Increased tourism adds pressure. Vehicles compress soil and disrupt wind patterns. Preservation here depends on maintaining absence. Less presence means more protection. The valley challenges the idea that landscapes must be lush or dynamic to be meaningful. It offers no water, no shelter, no resources. Yet it holds attention through exposure alone. Everything is visible. Nothing is concealed. Geological time is laid bare. Standing in the Valley of the Moon, it becomes clear that erosion does not always smooth. Sometimes it reveals. Sometimes it sharpens. Sometimes it leaves behind forms so stark they feel unfinished. This is not a landscape shaped by cycles of growth and decay. It is shaped by persistence. Wind persists, dryness persists, salt persists, and so the land remains locked in a state that feels eternal, even though it is slowly changing. The Valley of the Moon is not dramatic because something happened suddenly here. It is dramatic because almost nothing has happened for a very long time. No rivers rearranged it, no forest reclaimed it, no soil covered its scars. What you see is what remains after everything else failed to arrive. In northern Chile, beneath one of the clearest skies on Earth, the Valley of the Moon stands as a reminder that landscapes do not need life to tell stories. Some stories are written by what is missing: a place shaped without water, a land preserved by dryness, a surface so exposed it feels unfinished. The Valley of the Moon does not imitate another world. It shows what Earth becomes when stripped to its limits and left there long enough for silence to take shape. The cave that built its own world. Deep in the remote forests of central Vietnam, hidden beneath the limestone mountains and dense jungle, there's a cavern so vast it contains its own weather, its own rivers, and its own forest. Clouds form inside it. Sunlight reaches its floor through collapsed ceilings. Trees grow hundreds of meters underground. This is not a network of chambers or tunnels. It's a single, continuous space, on a scale usually reserved for the landscapes above ground. This is Son Doong Cave, the largest known cave on Earth. The Son Doong Cave lies within Phong Nha Bang National Park, a UNESCO World Heritage Site in central Vietnam. The park is already famous for its extensive cave systems, but Son Doong stands apart even here. It is not simply the largest cave discovered so far. It is a geological anomaly, formed through a rare alignment of rock, water, time, and collapse. Son Doong remained hidden from the world until remarkably recently. In 1991, a local man named Ho Khan was walking through the jungle when he noticed a strong wind blowing from a hole in the mountainside. Inside, he heard the sound of rushing water. The opening frightened him. He moved on and forgot the exact location. For nearly 2 decades, the cave remained unknown to science. It was not until 2009 that British cave explorers, guided by Ho Khan, rediscovered the entrance and ventured inside. What they found challenged everything known about caves. The passage opened into a cavern so large that conventional measuring tools felt inadequate. Stalagmites rose higher than buildings. A river flowed through the darkness. The ceiling disappeared into blackness above. The cave was named Son Doong, meaning Mountain River Cave. Its size is difficult to comprehend. Son Doong stretches for over 9 kilometers. In places, it is more than 200 meters wide and nearly 150 meters high, large enough to fit an entire city block, skyscrapers included, inside its chambers. By volume, it surpasses every other known cave on Earth. But size alone does not explain Son Doong's uniqueness. The cave formed around 2 to 5 million years ago, relatively young in geological terms. It developed in limestone bedrock laid down hundreds of millions of years earlier when the region was submerged beneath ancient seas. Limestone dissolves easily in weakly acidic water. Rainwater absorbs carbon dioxide from the atmosphere and soil, forming carbonic acid. Over time, this acidic water seeps into cracks in limestone, slowly widening them. In most caves, this process creates tunnels and chambers that branch and loop. In Son Doong, something different happened. A powerful underground river exploited a major fault line beneath the mountain. Rather than dispersing into multiple passages, the water concentrated along this weakness, carving a single massive conduit. Over millions of years, the river hollowed out a cavern far larger than typical cave systems. Then gravity intervened. Sections of the cave ceiling collapsed, opening massive skylights. These collapses allowed sunlight to penetrate deep underground, triggering changes no cave system had experienced before. Where light entered, life followed. Inside Son Doong, entire jungles now grow underground. Known as dolines, these collapsed areas host forests complete with trees, vines, insects, and birds. The plants draw moisture from cave mist and sunlight from above, creating ecosystems isolated from the surface world. Some plant species inside the cave show signs of divergence, adapting to low light, constant humidity, and mineral-rich soil unlike anything above ground. Clouds form inside Son Doong. Warm air rising from the cave's interior meets cooler air from above, causing condensation. Fog drifts through the cavern, clinging to stalagmites and trees. Rain falls inside the cave, not from the sky, but from condensation. This internal weather system is one of Sundung's most extraordinary features. The cave also contains some of the tallest stalagmites ever recorded, over 70 meters high. These massive formations grew over hundreds of thousands of years as mineral-rich water dripped from the ceiling, depositing calcite layer by layer. Unlike stalagmites in smaller caves, these formations grew uninterrupted, protected from surface erosion and disturbance. The river that carved Sandung still flows through it today. During the rainy season, water levels rise dramatically, filling large sections of the cave and making parts inaccessible. In the dry season, the river recedes, revealing sandbanks, boulders, and sculpted rock floors. The cave's walls display clear evidence of this history. Smooth, water-polished surfaces near the floor, and jagged collapsed debris higher up. Sound behaves strangely inside Sandung. Voices echo for seconds. Water sounds travel unpredictably. In some chambers, silence feels absolute. In others, dripping water creates a constant, distant rhythm. Light is absorbed rather than reflected. Even powerful headlamps barely illuminate the cavern's scale. Perspective collapses. Depth becomes hard to judge. Explorers describe a sense of disorientation, not fear but awe. Human history inside Sundung is minimal. Unlike many caves used for shelter, ritual, or storage, Sundung's sheer size and isolation kept it inaccessible. There are no ancient artifacts inside, no carvings, no signs of long-term human use. The cave remained a geological space, untouched. This absence has become part of its value. Today, access to Sandung is strictly limited. Only a small number of guided expeditions are allowed each year. Visitors must trek through dense jungle, cross rivers, and descend steep passages to reach the cave. Inside, strict rules apply. Nothing is removed. Nothing is left behind. Paths are carefully controlled to avoid damaging fragile formations and ecosystems. Preservation is critical. The cave's balance is delicate. Introducing contaminants, light sources, or excessive foot traffic could alter airflow, humidity, and biological systems that took millions of years to develop. Scientists continue to study Sandung carefully. Its isolated ecosystems offer insight into evolution in closed environments. Its mineral formations provide records of past climate conditions. Its size challenges existing models of cave formation, forcing geologists to reconsider how water, rock, and time interact on large scales. Sandung also has implications beyond Earth. Similar cave systems are believed to exist on Mars and the Moon, lava tubes and subsurface voids that could offer shelter for future exploration. Studying Sandung helps scientists understand how large underground spaces remain stable and how life might persist in darkness. Despite its fame, much of Sandung remains unexplored in detail. New passages continue to be mapped. New species are discovered. The cave is not finished revealing itself. Above ground, the jungle shows little sign of what lies beneath. Trees grow, birds fly, rivers flow normally. Without knowing where to look, one could walk nearby and never suspect that a hidden world exists below. This contrast defines Sandung. It is not marked by monuments. It does not announce itself. It does not rise above the land. It exists entirely beneath it. Sandung challenges how we think about landscapes. We tend to define the world by surfaces, mountains, valleys, rivers, coastlines. Sandung reminds us that some of the planet's most extraordinary spaces are hidden from view. Entire worlds can exist underground. Worlds with rivers, worlds with weather, worlds with forests, worlds shaped slowly, patiently, by forces that don't need sunlight or air. Sandung is not a place humans built, conquered, or reshaped. It is a place humans discovered and must now protect. In the mountains of central Vietnam, beneath jungle and stone, the largest cave on Earth continues to exist, quietly growing, dripping, flowing, and evolving on its own terms. A hidden landscape, a world beneath a world, a reminder that even now, the Earth holds spaces vast enough to humble everything we think we know about scale. The collapsed mountain that became a world. In northern Tanzania, where the highlands rise gently toward the Serengeti Plains, there's a vast circular basin so perfectly formed that it looks engineered rather than natural. Steep walls surround a green interior filled with grasslands, forests, lakes, and one of the densest concentrations of wildlife on Earth. From the rim, the view feels complete, contained, balanced, and strangely self-sufficient. This is not a valley carved by rivers or a depression worn down by erosion. It is the remains of a mountain that destroyed itself and, in doing so, created an ecosystem unlike any other. This is the Ngorongoro crater, the world's largest intact volcanic caldera and one of the most extraordinary natural structures on the planet. Ngorongoro crater formed approximately 2 to 3 million years ago, when a massive shield volcano, once taller than Mount Kilimanjaro, erupted catastrophically. Instead of exploding outward, the volcano emptied its magma chamber so completely that the mountain could no longer support its own weight. The summit collapsed inward. What remained was a caldera nearly 20 kilometers wide, with walls rising over 600 meters from the crater floor. Unlike many calderas that later erode or fill in, Ngorongoro remained remarkably intact. Its circular rim held firm, sealing off the interior and creating a natural enclosure. This enclosure changed everything. Rainwater flowing from the crater rim collects inside, feeding springs, streams, and wetlands. Because there's no major outlet, nutrients remain trapped within the basin. Over time, this created a self-contained ecosystem capable of supporting extraordinary biodiversity. Ngorongoro is often described as a natural zoo, but this comparison understates its complexity. The crater is not managed habitat. It is a functioning ecological system shaped by geology, climate, and time. The crater floor covers roughly 260 square kilometers and contains multiple distinct environments. Open grasslands dominate the center, supporting grazing animals. Swamps and marshes fed by underground springs provide permanent water sources. Acacia woodlands grow along the slopes. At the center lies Lake Magadi, a shallow, alkaline lake that expands and contracts seasonally. This variety allows many species to coexist in close proximity. Ngorongoro supports over 25,000 large animals year-round. Wildebeest, zebra, buffalo, and gazelle graze the plains. Elephants move between forested slopes and open ground. Hippos crowd into pools and wetlands. Flamingos gather at Lake Magadi when conditions allow. Predators thrive here as well. Lions are particularly abundant, with some of the highest densities recorded anywhere in Africa. Hyenas patrol constantly. Leopards hide in forested areas. Cheetahs hunt across open grasslands. Jackals move between niches. What makes this concentration possible is stability. Unlike surrounding ecosystems where animals migrate, seasonally in response to rainfall, Ngorongoro offers permanent water and grazing. Many species remain inside the crater year-round, rarely leaving its boundaries. The caldera walls act as both barrier and shelter. They limit movement, which reduces dispersal but increases interaction. Predators and prey encounter each other more frequently. Competition is intense. Survival is visible. This visibility is part of Ngorongoro's power. Unlike vast landscapes where animals disappear into distance, here life unfolds within view. The scale allows observation of entire food webs functioning simultaneously. Yet, Ngorongoro is not isolated from history. Human presence in the region stretches back millions of years. Just beyond the crater lies Olduvai Gorge, one of the most important paleoanthropological sites on Earth. Fossils found there document early human evolution, including some of the oldest known stone tools. This proximity links Ngorongoro not only to wildlife history, but to human origins. The Maasai people have lived in the Ngorongoro region for centuries. Traditionally pastoralists, they moved cattle through the highlands in seasonal patterns that coexisted with wildlife. Their presence shaped the landscape through controlled grazing and fire management. When the Ngorongoro Conservation Area was established in 1959, it was designed as a multiple-use landscape, one of the few protected areas in Africa where wildlife conservation and human habitation were intended to coexist. This balance has been difficult to maintain. As human populations grew and conservation priorities shifted, restrictions increased. Today, Maasai are not permitted to live inside the crater itself, though they continue to inhabit surrounding areas. Their cattle may graze in limited zones under regulation. Ngorongoro thus exists at the intersection of conservation, tourism, and human rights. Its beauty inseparable from complex social questions. From a geological perspective, the crater is a rare example of a caldera preserved at full scale. Most volcanic calderas erode over time, breach at low points, or fill with sediment. Ngorongoro's rim remained intact due to its relatively young age and resistant rock. The volcanic soils inside the crater are exceptionally fertile. rich in minerals. This fertility fuels plant growth, which in turn supports large herbivore populations. But fertility also brings vulnerability. During dry seasons, overgrazing can stress vegetation. During wet seasons, flooding can alter habitats. Disease spreads more easily in confined populations. The system is productive but tightly balanced. Climate change adds uncertainty. Shifts in rainfall patterns could alter water availability. Prolonged droughts could reduce grazing. Extreme rains could flood wetlands and change lake chemistry. Because the crater is enclosed, its ability to adapt is limited. Ngorongoro's beauty hides this fragility. From the rim, the crater appears timeless, green, full, complete. But its balance depends on conditions that can change quickly. The rim itself plays a critical role in shaping climate inside the crater. Moist air rising from the plains cools as it reaches the highlands, condensing into clouds that often linger along the rim. This creates a microclimate with slightly cooler temperatures and higher moisture inside compared to surrounding areas. Fog frequently drifts over the rim at dawn, descending into the basin. This moisture supports vegetation even during drier periods. Sound behaves differently here. The crater walls reflect and contain noise. Animal calls carry across the basin. Thunder echoes repeatedly. Silence feels enclosed rather than open. At night, the crater transforms. Predators become active. Lions roar, their calls reverberating against the walls. Hyenas laugh across the plains. The sense of enclosure intensifies. There's no easy escape for animals or sound. Ngorongoro is often compared to Eden, but this comparison can be misleading. Life here is abundant, but not gentle. Predation is constant. Competition is relentless. Death is visible and frequent. What makes Ngorongoro exceptional is not harmony, but completeness. All parts of the system are present. All interactions occur within view. Nothing is hidden. This completeness is rare. It is also temporary. Over geological time, the crater will change. Erosion will lower the rim. Sediment will fill the basin. Lakes will shift. Vegetation will change. Eventually, the caldera will lose its enclosure and become another valley. But for now, it remains intact. A snapshot of Earth's capacity to rebuild after destruction. A mountain collapsed. The ground fell inward, and life moved in. The Ngorongoro crater is not a place where nature avoided catastrophe. It is a place where catastrophe created opportunity, a reminder that destruction does not always mean absence. Sometimes it creates space. In northern Tanzania, beneath a broken mountain rim, a world continues to exist, contained, intense, and alive, shaped by fire long gone, sustained by water trapped inside stone. Ngorongoro is not just a crater. It is a closed chapter of the earth that remains open long enough for us to witness it. A collapsed mountain, a living basin, a complete world held inside a circle of rock. The shoreline that walks away. On the eastern coast of India, along the Bay of Bengal, there's a beach where the ocean does something that feels impossible. Instead of retreating a few meters at low tide, the sea pulls back for kilometers. The shoreline empties. Wet sand stretches to the horizon. Fishing boats sit stranded on bare ground. For hours, the ocean appears to vanish completely, before returning just as quietly as it left. This is Chandipur, a place where the boundary between land and sea refuses to stay in one place. The Chandipur, often called Chandipur on Sea, lies in the state of Odisha on India's eastern coastline. What makes it extraordinary is not storms, cliffs, or dramatic waves, but rhythm. Twice a day, the sea retreats up to 5 kilometers, exposing a vast tidal plain rarely seen anywhere else on Earth. This phenomenon is not illusion. It is physics, geography, and timing aligning with unusual precision. Most coastlines experience tides, but Chandipur's tides behave differently. Here the sea does not simply lower its level, it withdraws horizontally across an extremely gentle seabed. The slope of the coast is so shallow that even a small vertical drop in sea level translates into a massive horizontal retreat. The land beneath the water is almost flat, an expansive shelf composed of fine sand, silt, and clay, deposited over thousands of years by rivers flowing into the Bay of Bengal. This gentle gradient is the first key to Chandipur's vanishing sea. The second key is tidal range. The Bay of Bengal experiences complex tidal dynamics, influenced by the shape of the coastline, the Coriolis effect, and lunar gravitational forces. In Chandrapur, these forces combine to create unusually pronounced low tides that expose the seabed far beyond what most beaches ever reveal. When the tide retreats, it does so slowly and silently. There are no crashing waves pulling back, no dramatic surf. The water simply slides away, leaving behind rippled sand, shallow channels, and tidal pools. For hours, the horizon appears empty of water. Then, just as quietly, the sea returns. This returning tide advances steadily, reclaiming the exposed land without warning signs. Visitors unfamiliar with the rhythm can find themselves surrounded if they are not paying attention. The sea here is calm, but not forgiving of inattention. Geologically, Chandrapur sits within one of the most sediment-rich coastal systems in the world. Rivers like the Subarnarekha and Buddhabalanga carry enormous volumes of sediment from the Indian subcontinent into the Bay of Bengal. Over millennia, these sediments spread along the coast, creating wide tidal flats and deltas. Unlike rocky coasts shaped by erosion, Chandrapur is shaped by accumulation. The beach is not carved, it is built. This constant supply of sediment keeps the shoreline shallow and mobile. Sandbars form and disappear. Channels shift. The exact pattern of exposed land changes subtly with each tidal cycle. This makes Chandrapur feel unstable. Not violent, but uncertain. The exposed seabed reveals an environment rarely seen by humans. Small fish, crabs, starfish, and mollusks become visible, stranded temporarily in shallow pools. Local fishers walk far out onto the flats, collecting fish by hand or with simple nets. Children run across the sand where boats normally float. Birds gather in large numbers, feeding on exposed marine life. The sudden availability of food turns the retreating sea into a moving banquet. This daily cycle has shaped life here for centuries. Local communities adapted their fishing methods to the vanishing sea long before it became known as a tourist curiosity. Fishing schedules follow the tide precisely. Knowledge of timing is passed down, learned through observation rather than instruments. The sea dictates routine. When the water is gone, the land is usable. When it returns, the land disappears. This constant negotiation with the ocean defines Chandrapur's human relationship. Historically, Chandrapur was not isolated. It served as a minor port during colonial times, particularly under British administration. Its unusual tides made it both useful and dangerous. Boats could anchor safely during high tide, but risked being stranded during low tide. Over time, larger ports replaced Chandrapur, and the town became quieter. Its defining feature, the vanishing sea, remained. Scientifically, Chandrapur offers valuable insight into coastal dynamics. Tidal flats like these are sensitive indicators of sea level change. Small shifts in global sea level can significantly alter how far and how often the seabed is exposed. Because Chandrapur's slope is so gentle, even minor changes could transform the phenomenon entirely. Climate change adds uncertainty. Rising sea levels may reduce the extent of retreat. Altered sediment supply from dammed rivers could change the seabed's shape. Stronger storms could reshape the coast abruptly. The vanishing sea is not guaranteed to vanish forever. Ecologically, the tidal flats act as buffers. They absorb wave energy, reducing coastal erosion during storms. They trap sediments and nutrients. They support diverse species adapted to alternating exposure and submersion. This makes Chandrapur not just a spectacle, but a functioning system. The absence of dramatic waves also shapes perception. The sea here feels gentle, almost passive, but this calmness is deceptive. The returning tide can move faster than expected, especially during spring tides when lunar alignment intensifies tidal forces. Warnings are subtle. There are no sirens, no sudden surges, just water steadily advancing. This reinforces a theme that defines Chandrapur: change without drama. The beach looks ordinary at first glance. No cliffs, no unusual rock formations, no striking colors. And yet, its behavior is exceptional. The wonder is not in appearance, but in motion, or absence of it. At sunrise, when the sea has withdrawn, the exposed flats reflect light like a mirror. The sky doubles itself on wet sand. At sunset, the returning water glows orange and gold, slowly erasing footprints and tracks. Night transforms the experience again. Under moonlight, the boundary between land and water becomes difficult to see. Reflections blur. The tide advances silently. The landscape feels unreal, not because it looks alien, but because it behaves unpredictably. Culturally, Chandipur occupies a quiet place in India's vast coastal narrative. It's not associated with mythic destruction or divine intervention. There are no grand legends explaining the sea's behavior. Instead, the phenomenon is accepted as part of daily life, a natural rhythm rather than a miracle. This acceptance is revealing. For those who live here, the vanishing sea is not mysterious. It is familiar. The mystery exists primarily for outsiders encountering it for the first time. This contrast highlights how perception depends on expectation. We expect the sea to stay. Chandipur shows it doesn't have to. The beach challenges assumptions about permanence. Coastlines feel stable in human memory, but they are among the most dynamic landscapes on Earth. Chandipur simply makes that dynamism visible. Most coasts change invisibly, centimeters per year, masked by waves. Here, change happens in front of you, measured in footsteps and hours. It is geography made obvious. Chandipur also forces reconsideration of distance. When the sea retreats 5 kilometers, the scale of the ocean becomes tangible. What was once a thin line becomes a vast absence. Standing on the exposed seabed, the horizon feels too far away. The sound of waves disappears. The smell of salt lingers without water. It feels like trespassing, not on land, but on something usually hidden. Then the sea returns and erases the experience. No trace remains. No marker shows how far it went. Only memory. This cyclical erasure gives Chandipur a transient quality. Nothing here is meant to last. Footprints vanish. Channels shift. The beach resets twice a day. In a world increasingly focused on permanence, walls, borders, fixed infrastructure, Chandipur offers the opposite lesson. The boundary between land and sea is negotiable, temporary, moving. For scientists, it is a natural laboratory. For locals, it is routine. For visitors, it is unsettling. The vanishing sea does not roar. It does not threaten. It simply withdraws. And in doing so, it reveals how much of our certainty about landscapes is built on habit rather than truth. On the coast of Odisha, along a quiet stretch of the Bay of Bengal, the sea walks away every day, leaving behind a reminder that even the most familiar forces on Earth do not owe us consistency. Chandipur is not defined by what it shows. It is defined by what it removes. A shoreline without water, a sea that refuses to stay, a place where absence becomes the most powerful presence of all.